and welcome to the Exploratory Data Analysis, i.e. EDA module of Fluidsdata. This module provides a complete set of tools for visualization, exploration, and interpretation of your fluids characterization data. From simple data views to advanced multidimensional plots, each section is built to make complex data exploration straightforward and intuitive. First step of EDA is usually inventory analysis that summarizes how many data sets you have for each variable. On the right side, you'll find a comprehensive set of filters, covering fluid type, classification, sample, asset, field, reservoir, well, and sample ID. These filters apply across all plots in this workspace, ensuring every view stays consistent with your chosen scope. Beneath the filters, you can choose the component range, fluid phase, and data type, followed by drop-downs for non-hydrocarbons, hydrocarbons, plus fraction properties and composition bulk properties. Each of these drop-downs comes with a default selection, so you'll always see a meaningful set of plots right away. For example, in non-hydrocarbons, CO2 is already selected, and hence this plot shows up by default. You'll also see test analysis drop-downs for CCE, DL, viscosity, and CVD tests. Selecting any of these instantly generates the corresponding plot in the main view. All filters on the right are common throughout the EDA submodules. Next, we'll move on to 2D histograms and KDE plots to further explore data relationships. The EDA submodules will pave the way for AI model building. Here is divided into two columns. On the left, the 2D histogram plots, and on the right, the KDE plots. Let's do an example. Start by selecting multiple assets. The plots immediately refresh, showing updated distributions for that section. Next, choose two fields and watch how both columns update to reflect those inputs. You can also refine the view by selecting a variable range, which activates a slider. Adjusting the slider values dynamically filters the data. All plots are updated as per the selected range of the fluid's property. This is a very important and common feature across all EDA submodules. By default, the screen always presents pre-configured plots that surface useful insights from the data. The same plots are also listed at the bottom of the right-hand panel, where you can add or move a plot. This way, your main screen and control panel will always stay in sync, giving you full flexibility to tailor the analysis. Next, we'll move into statistical analysis to uncover panels and trends from a more quantitative perspective. The statistical analysis module provides visualizations and description statistics for fluid sample. It helps users identify distribution patterns, outliers, and statistics in the fluid data across different variable groups, like composition components, plus fractions, composition bulk properties, and PVT tests. For each variable group, the system generates a dedicated plot using the components selected. For example, here in the non-hydrocarbons group, we can quickly remove one component by unchecking it, and the plot updates instantly. Below the composition range filter, there's a toggle that lets you switch view model between a box plot view and a summary table, giving you flexibility depending on whether you want visual trends or numeric statistics detail. Looking at the box plot for non-hydrocarbons, we can also interpret the quartiles. The box highlights the middle 50% of values. The line marks the median, and the whiskers show the spread of data. This makes it easy to spot variability or outliers across samples for a given variable. Now that we've explored distribution and variability through statistical analysis for individual variables, the next step is to understand how different variables relate to each other. For this, we'll move on to the correlation analysis module, which highlights relationships between fluid properties and helps uncover hidden relationships and insights that can help you take reservoir and production decisions. Correlation analysis is divided into two sections: correlation matrices on the left and scatter plots on the right. Both Pearson and Spearman correlation methods are available, allowing users to compare linear and rank-based relationships. At first, the scatter plot area is empty. A plot is only drawn when a user hovers over or clicks a cell in the correlation matrix. For example, selecting saturation pressure versus C1 automatically draws its scatter plot. Choosing density versus C7 plus updates the plot with that relationship. I am now selecting RS versus C7 plus to show it in the scatter view. Filters on the right can be applied to include only certain variable groups, making it easier to focus on specific relationships. This makes correlation analysis a powerful way to visualize dependencies and trends across assets, wells, and reservoirs. You can also use this module to identify the fluid analogs. Let's move to heat map analysis, which offers a more visual way to highlight clusters and patterns. By default, a feature is pre-selected to display the data. In this demo, we start with an API variable. The heat map is hierarchically grouped, first by asset, then by field, and finally by well. Each cell represents the selected component value at that level of grouping. Hovering over a cell provides quick details showing the asset, field, well, and the exact volume of the component. If I click a cell, the heat map drills down, allowing me to focus on more specific data for that component. I can always return to the higher level view using the heat map navigation at the top. On the right side, filters can be applied to narrow the dataset, while the drop-down below data type lets me switch the component being analyzed. Users also have flexibility to change the heat map color style, choosing between the palettes. This combination of drill-down navigation, filtering, and styling makes the heat map a powerful tool for spotting cluster patterns and variability across assets, fields, and wells. Next, we'll transition into bubble plot analysis, which helps visualize multidimensional relationships in a more comparative way. By default, several plots are already displayed so users can immediately see meaningful comparisons. Each bubble represents a data plot, with its position, color, and size reflecting the assigned features. Filters on the right panel allow us to refine the dataset, while the Add Plot option provides flexibility to create new visualizations. Here, users can specify the X and Y axes, Z as size feature, as well as the color feature, tailoring the analysis to highlight particular variables, relationships, or property trends of interest. This interactive setup makes it easy to highlight trends, clusters, or anomalies across multiple components in a single view. Bubble plots provide four-dimensional visualization in a 2D plot. Let's move into 3D plot analysis, where multidimensional trends can be examined in greater depth. The 3D plot analysis menu opens with a set of pre-configured plots so users can immediately start exploring multivariate relationships. These views give a quick sense of trends and clusters across assets and wells. To narrow down the dataset, filters on the right side panel can be applied, whether by asset, field, well, reservoirs, or other parameters. This ensures the analysis stays focused on the subset of interest. We can also generate a new visualization by selecting the X, Y, and Z axes from any variable, then assigning color by asset, field, well, or reservoir. This grouping highlights whether compositional variability is primarily driven at the asset level, between fields, or down to the well or reservoir scale. For example, plotting C1, C2, and N2 on the axis and coloring points by field helps reveal whether certain fields share consistent compositional signatures or stand out with distinct trends. With this, we now move to the compositional gradient analysis, where subsurface vertical variations in fluid properties can be examined in more detail. By default, you'll see several key points displayed. For example, C1 versus depth, API gravity, gas to oil ratio, saturation pressure, and test temperature. Any other variables of your choice can be added for compositional gradient analysis. On the right, the filter panel lets you refine the dataset by asset, field, reservoir, well, or individual sample IDs. Here, I'll select a few samples that I want to examine. Notice how the plots immediately update. The y-axis still represents the chosen components, but now only the measures from the selected samples are displayed. This provides the ability to compare multiple samples across wells or reservoirs, making it easy to spot composition gradients, vertical variations, and anomalies in the fluid's properties instantly. In short, composition gradient analysis acts as your scientific and engineering toolkit to make better reservoir engineering decisions which you may have missed otherwise. To recap, the EDA module lets you navigate across multiple analysis to help uncover unique insights, trends, and anomalies across assets, fields, wells, and reservoirs, helping you contact high-level patterns with detailed reservoir behavior. That wraps up the EDA module video. Feel free to reach out to us if you want to dive deeper or save the cost of fluid sampling and characterization.